Okay, so we're going to use an inverse. This is kind of similar to the gravel problem we did earlier. So let's read it. The function C equals, and then they give us this formula, represents the concentration of C. Okay, so C is for concentration of an acid solution after n milliliters of 40% solution has been added to 100 milliliters of 20% solution. All of this stuff, that wording, that's all included in the formula, right? You can see the 100, you can see the 20, you can see the 0.4. Okay, you can see those numbers in there. Okay, make sure I typed it right. First, find the inverse of the function. That is, find an expression for n in terms of C. Okay, so this is where the difference comes in. I'm going to rewrite it. Now, what did n represent? We want to remember that. So n is milliliters of 40% solution. Okay? So remember that's what n is. And what is C? C is concentration. Okay. So now we're going to write this formula they gave us. We need to get it n by itself. So the first thing I'm going to do is I'm going to multiply by 100 plus n on both sides. Okay, then that's going to give me on the left 100C plus Cn equals 20 plus 0.4n. I'm trying to get n by itself. So what I have to do in this case, you'll notice n is in two terms, one on the left and one on the right. I need to get the n's together on one side and everything else on the other side. So I'm going to write Cn minus 0.4n equals 20 minus 100C. Okay? So what I'm doing there is I'm taking the 100C over here. That was supposed to be in orange. I'm taking the 100C over here, and I'm taking the n term to the other side. The n term to the other side. Okay? So I got Cn stays put. That's right there. This term's coming over, so Cn minus 0.4n. And then the 20 stays put, but the 100C, that part's going over. Okay? All right, so hopefully that was okay for you. Then you'll notice I have two terms on the left with n. I'm trying to solve for n. So I factor out n. And then I'm going to divide. I was all ready to divide. So n is going to equal 20 minus 100C over C minus 0.4. Okay? And that gets me n by itself. All right. Now we're supposed to use that formula. What does it say? Then use your result to determine how much of the 40% solution should be added so that the final mixture is a 35% solution. Okay. So we want to evaluate that formula. I'll have to scroll back down, but we want to evaluate at 35%. We're going to change 35%. That's the concentration, right? We're going to change that to a decimal number, 0.35. Okay, so that's what we'll be plugging in for C. All right, let me go back to my formula. So we're going to get here n is equal to 20 minus 100 times 0.35. Those of you going into nursing, make sure you put the 0 before your decimal. And then 0.35 minus 0.4. Okay. What did I do wrong? I don't think I did anything wrong. Okay, so at this point, you could pull out a calculator. I'm going to do a little bit by hand. So 20 minus, that's going to be 35. And then in the denominator, I'm going to have like negative 0.05. But again, you could use a calculator. And that gives me, here I am just doing it by hand, negative 15 divided by negative 0.05. For me, I would probably think about multiplying by 100 in both, so that I had something like negative 1500 divided by negative 5, and then I could see, oh, the answer is going to be 300. But, you could just put it in a calculator too. Now remember, N was in terms of milliliters, so it's going to be 300 milliliters. That's how much we need to put in to get the 35% concentration. Okay.